In this video, I'm going to show you how to recreate this engineering drawing for IME 143, IME 144, or IME 145's first lathe project. Before you can create this engineering drawing, you first have to create a solid model of the part. If you haven't done so, go ahead and create the solid model. If you need help, there's a video tutorial to show you how to create the part from start to finish using 4 features. But nevertheless, we're going to go ahead and open up SolidWorks. We're going to close our part file down. We're going to go File, New, and we're going to select Drawing. Select OK. Our next step is to select the template or title block we want to use for our engineering drawing. I'm going to go ahead and use the 144 SolidWorks drawing template that was provided for you on PolyLearn. Now, if you need help installing this template, there are other tutorials that will go ahead and show you how to install the template within SolidWorks. But for now, press OK. And our whole goal is to go ahead and create the drawing views. I could use Model View right here by selecting Browse and selecting my part file, but I'm going to hit X and show you a couple of other things before I go ahead and insert my views. What I'm going to do is I'm going to go to my View Layout tab, and there's really 2 main ways to start off your engineering drawing. You could do Standard 3 View or Model View. In this video, I'm going to go ahead and show you Standard 3 View. I'm going to hit Browse. I'm going to select Lathe Project 1, Camtasia Video Demo, and select Open. What that does is it places 3 views, 3 standard views, the front and the top. On symmetrical parts, a lot of the times you'll have 2 of the views exactly the same on lathe parts. So you'll notice the front and the top view are exactly the same. Hence, I'm going to show you how to delete a view. You simply click on the view and hit delete. And it makes sure that it asks you, are you sure you want to delete this view? All you do is you simply hit yes. And now we have 2 views that we need to define this part. Now by default, SolidWorks went ahead and put in 7/16 18 tapped hole. I'm going to go ahead and click on that and hit delete as well. Now what I wanted to do is show you the different ways to create engineering drawing views or use the projected view tool. So to do that, I'm going to go ahead and first look at the engineering drawing. I'm going to change the scale to 1:1, and then I'm going to show you how to create these other views before we start dimensioning it. So we're going to have to create a backside view, or basically a left side view, sorry, and we're going to have to create a detail view. So to do that, let's move back to SolidWorks. I want to make sure my title block has the correct scale, because when I inserted it as a half scale. So I could click on the drawing view, the main one, drag down, and select Use Custom Scale 1:1. Or I could keep Use Sheet Scale. I could come down here to Sheet 1, right click on it and go to Properties and change my scale to 1:1. Notice it automatically changes my drawing views for me. The second way I just showed you is probably the better way. I'm also going to delete the center mark because we're going to create those manually, just in case you didn't know how to do that. So moving over here, I got to go ahead and create a left side view. So I'm going to use my projected view tool. I'm going to click on the front view and drag out the left side's projected view. I could drag out, also at the same time, drag out an isometric if I move my mouse up towards the diagonally towards the right top. It'll go ahead and project a view. If I move it over straight to the top, it'll create a top view, which is the same as the front view. So we're going to make isometric view like you see there. Now, I'm going to drag this one over, and I want to show hidden lines on my views. But before showing you how to change it to hidden lines, I'm going to delete the tapped hole, call out, and I'm going to delete the center mark. We're going to do everything from scratch. So at this point, if I want to show hidden lines on my drawing views, I could select that drawing view, and over here on the left side I could select Hidden Lines Visible, and it shows up with all hidden lines on all the views. Now my pictorial view kind of gets messy if I show all the hidden lines, so I'm going to click on the pictorial view, and at the top I'm going to change my display style. It's the same as changing it over here as changing it in the top. I'm going to select visible lines only for my pictorial view. It really cleans up that pictorial view. So now, the last view we have to create, going back to the engineering drawing, is this detail view, which notice we have a circle here with a phantom line around it technically, and it's detailing what you see in the detail view. So to do that, we go back to SolidWorks, we go up here under View Layout to Detail View, and you simply zoom in and click where you want the center of the circle to be. At this point, you drag up and you make sure that the circle encompasses everything you want to see in your detail view, and then click your left mouse button again. What that'll do is it'll create a detail view. Now, this view has a scale of 2:1 in this drawing. I believe the example is a 4:1 scale. So you'll see that right there. Let's go back and look. You'll see we have the 4:1 and then the 1:1 scale for the major views. So you can blow up your detail views to a different scale other than the scale on the engineering drawing. So moving back to SolidWorks, you'll also just notice that there's no arrows in my detail view. The reason is I'm in ISO standards. I'm not in ANSI. This seems to be a bug in SolidWorks, where that when I go to my options, you'll see it shows document properties. It says it is ANSI. So if I was to pick ANSI, press OK, nothing really happens. So what I'm going to do is I'm going to go to Options. I'm going to take it off of ANSI and go to ISO. Press OK. Then I'm going to go back to my same options again, and I'm going to go to ANSI and hit OK. What that does is it creates the arrowheads for the detail view. Now, I don't really need to show the scale of my detail view, so I'm going to double click on that and just delete the bottom line in that text box. And I'll go ahead and label the detail view right there. So what we've done, I'm going to move it over. We have created a detail view, like you see right here, and we have created the front view, the right view, and the left view for the lathe part. We've created all the views needed to fully define the part once we add dimensions. Now, what we're going to do is we're going to move back to SolidWorks, and I'm going to drag this down slightly, and we're going to start dimensioning the part. I'm going to drag this down a little bit more. The first thing I want to add is I want to go ahead and add a thread callout. So to do that, I can go to my annotation, and you'll see if you created a hole with the hole wizard and you select hole callout, SolidWorks will go ahead and create the thread callout for you. So when I click on the line, the visible line, you'll see it drops down and it gives me the 3/816 UNC depth 0.75. It also gives me the hole's depth and the diameter of the drill that I need to use in order to create the hole before I use the tap. However, we really just want to go ahead and call out the thread. We'll let the manufacturing engineer figure out how deep to drill the hole, or if it's really important, we can put it up in the notes section. So when the dimensions highlighted, you'll notice all the dimension text that shows up automatically is over here. So if we wanted to add anything or take anything away, like I want to remove this upper line, I can come over here to this dimension text, highlight the entire upper line, and click delete. What that does is it deleted the whole upper line and gave me my thread callout. So let's try that again over here on our other thread. So what I do is I select hole callout, I click on the visible line, I drag down, I place my dimension. Now to get rid of the upper hole's callout there, I'm going to go ahead and drag over here in the dimension text. I'm going to highlight the entire top line and click delete. And that gives me my thread callouts. So looking back at the engineering drawing, you're going to see my drawing that I gave you is missing a center line that I'm showing. So we'll go ahead and properly put a center line in here. Sound good? Sorry about that. So moving back to SolidWorks, we're going to go ahead and click on center line. We're going to click that line, and it creates a center line through the part. Now when I click on the center line, I can easily drag it out. Next, we'll go ahead and we'll actually add a center line to the detail view, which is missing as well. And press escape to inlet tool, click on the center line. We'll end up dragging the center line a little bit shorter so it equally extends out of both sides of the view. Finally, I erased the center marks. They were automatically created, so you might have them on your drawing, but I wanted to show you how to create the center marks. So when I click center mark, I pick on the largest circle I have, and the center marks will extend past that largest circle. Perfect. So now we've got our two internal thread callouts. Let's go ahead and create our external thread callout, this half 13 2A. So moving over, you'll see it says half 13 UNC 2A. We're going to create that callout with a note. So moving back to SolidWorks, we click on note. I'm going to go ahead and click on the crest of the thread, drag over, click my mouse button, and key in 1/113, and then I'm going to press space UNC 2A. At this point, I'm going to click my left mouse button, press escape to in the note tool, and position the note exactly where I want to see it on my drawing. In fact, I'm going to go ahead and move this over a little bit more and try to make all the threads in line. So that way I don't overly cloud or basically clutter my drawing. So our next step is to go ahead and create the dimensions. We'll start with the front view because the left and the right views are fully defined or fully dimensioned according to the rules. And according to the positive cylinders rule, we're going to want to go ahead and dimension all the diameters, the external diameters in this front view from the side here. Front view, but really the side of the part technically. So to do this, we're going to use our Smart Dimension tool, and we're going to click basically on this line and drag out in order to grab the 0.925 dimension. Now by default, SolidWorks has specified a two-place dimension. You'll see right over here the precision specified by the document right there, which we could change that up in our options, but for right now, I'm going to go ahead and just click on 3 decimal places and make that 925 dimension. So looking at the engineering drawing that was provided to you, you'll see we want to place the 625 and the 493 diameter along with the 4-inch diameter dimension. So let's go do those 3 right now. So moving back to SolidWorks, I'm going to go ahead and click on use Smart Dimension and go from there to there, there to there, drag outwards, and place the 4.400 dimension. So what I'll do is I'll go ahead and change the precision to 3 decimal places, and you'll see there's a small visible gap between the extension line and the visible line in our detail view. Now, you don't want things to overlap, so make sure you pull the 0.4 diameter off of the center line. The next dimension we're going to do is the 625 diameter. So we'll click on that vertical line that represents the 625's diameter, drag out, and change the precision to 3 decimal places. And press escape in the Smart Dimension tool for now. The last one we're going to create is the 493 based off the major diameter or the crest of the threads. So to do that one, I'm going to grab Smart Dimension. I'm going to dimension from this line up here, this line up here to this line down there and drag outwards. Now when I make it 3 decimal places, you'll see the 493 comes up. But looking back at the drawing, you'll see it's a reference dimension. It's really the half 13 dimension right here, or call out, sets up the true diameter for the thread. So we look up the diameter for a 2A half 13 thread, and it ends up being the 0.493. So our next step is to go ahead and arrange our dimensions a little bit better in SolidWorks. To do that, we want to make sure the smaller diameter comes before the 625. And I want to make this a reference dimension. So when I click on the 493, in order to put brackets or parentheses around your dimension to signify that it's reference and it's not inspected in manufacturing, we click on the reference dimension, and then we literally spread everything out so we're not overlapping any of the lines. In fact, you'll see my center line ends with a short dash, so I'm going to fix that by moving it inwards slightly, and that way my center line ends with long dashes. So looking at our drawing, we have all of the diameters specified on here. The 400 thou, the 493, the 625, and the 925. What's next are the different lengths for our view. So to do that, I'm going to go ahead and I'm going to select Smart Dimension, and I'm going to dimension the edge of the part to the edge of the first protrusion and place the 2.00 dimension. Looking back at the engineering drawing, you'll see that one only has 2 decimal places, as does the overall 4 inches. However, the 0.875 from the front face of the part back to the 625 protrusion is a 3-place dimension. So we'll make sure when we place that one, we change the precision. So let's go back to the SolidWorks drawing, and we're going to go from this edge to the front edge of the part when I zoom in with my mouse and place the 4-inch dimension. Then I'm going to go from the front of the part when I zoom in to the back of the 625 protrusion and drag it out and change the precision to 3 decimal places. Now, looking at our drawing, we have the 825, the 2 inches, and the 4 inches. So really, this length of the 625 protrusion is dependent on this dimension and that dimension's tolerance and how they stack up. So our next thing to do is we're going to go ahead and we're going to move the detail A out of the way a little bit. We're actually going to slide it up a little bit. And we're going to create the angle dimension for the 30 degrees. Now you'll notice I have the thread relief specified down here on my drawing. So what I can do is I can use Smart Dimension to dimension from this line to this line right there and pull out the 30 degrees. Now because I placed my 30 degrees over the detail A, I'm going to move my detail A to over to the left side of it. Or I could have pulled out my angle right there. However, this seems to work well. Now last but not least, I want to dimension the length of the flat here on this drawing. So to do that, I'm going to use my Smart Dimension and go from that edge to that edge and place my 90 thou flat dimension. Now notice, my example placed the 30 degrees up there. However, as long as you show it, we're good. So you could either place it on the top or the bottom of the detail view. Moving back to SolidWorks, you're going to see my detail view actually didn't end up showing the point. So at any time you could drag out, you could grab the circle for your detail view and make it bigger or smaller. Just wanted to point that out, and it updates the view automatically. So at this point, we're ready to go ahead and add the chamfers and the note dimensions. So to do that, I'm going to go back to my drawing and show you that there's 2 50 thou by 45 degree chamfers. So when I move to SolidWorks, I could simply click on my Smart Dimension tool, and there's actually a chamfer dimension tool. So when I click chamfer dimension and I zoom in, I click on the hypotenuse of the chamfer and basically a straight edge in order to base the chamfer's angle off of. And that'll go ahead and place the 50 thou by 45 degree chamfer. However, since there's 2 of them on the part, I got to go ahead and put 2 by before the actual chamfer's dimension. So to do that, if you press escape, you unselected that dimension. So I got to reselect the dimension by clicking on it, going over here to the dimension text, and in front of the carets with the DIM in it, I type in 2 uppercase X space. And that gives me the 2 by 0.05 by 45 degree chamfer callout. At this point, I think I've done everything other than create my notes for my drawing in my title block and my notes up here. Now notice too, when I change the size of my detail view to show you how to do that, it kind of messes with my center line, so I'm going to shrink it back down so in my 400th thou diameter and my center line goes through my part appropriately. In fact, on this detail view, I could actually show it without hidden lines if I wanted to, and I might clarify the detail view a little bit more. I know the example that I gave you shows the hidden lines, however, it's up to you if you want to show those or not. Now moving back to SolidWorks, you're going to see that we've got to go ahead and create the date, the material, and the title. So to do that, I'm going to use my note tool. So when I click on note and I go down to the date, I click the text box in the date area and I type in the date 09-27-19 and I click my mouse button to end that tool. Now it'll copy that note if I needed to copy the same note somewhere else. So I can click down and press enter or click my mouse button if I want the same note, or notice the text is highlighted, so I can simply type in 6061-T6 space aluminum and key in the material. Now the title will be IME 144 Lathe Project number 1 drawing. And click down. Now my previous videos for showing you how to create engineering drawings showed you how to modify the title block and make the drawn by your name. So if you need help doing that, go back and learn how to right click, edit, and basically edit sheet format to change the actual title block or the name in the title block. The last thing we're going to do is we're going to go back up here and we're going to create the notes section. So we're going to write notes, chamfer 10 thou by 45 degrees unless specified. And we're going to give them the drill depths for the different taps. So to do that, we move back to SolidWorks. And we go ahead and we click on note. At this point, we're going to place our notes up here. I'm going to write notes 1.1, and I'll go ahead and write chamfer all edges 0.01 by 45. Now notice if you need a symbol in your notes, they're right over here underneath add symbol, and I could click on the degree in order to get the degree symbol on my 45 degrees. Then when I hit enter, it automatically gives me number 2. So number 2 is drill, see here, the depth, notice drill 1 inch depth for 3/8/16 tap. So I'm going to write drill 1.00. I don't even need to put the inches, that's actually improper. I go to my symbol, I select my depth. Notice the depth isn't there, so I go to more symbols, and I'm going to go find the whole symbols. And I can pick depth, okay, space, so 1 inch depth, and then for 3/8-16 UNC to be whole, or UNC2 or 3/8/16 tap. So I'll move back to SolidWorks and make it match exactly like you see. Clicking in there, 3/8/16 tap, then enter. Then I'll go ahead and write drill 1.25 space bar. We'll go to the symbols, depth for 5/16, so 5/16-18 tap. Now notice we created that note. If we wanted to, we could create it a second time or press escape to end the note tool. At this point, I think we've created everything on the engineering drawing like you see on the one given to you. Now if you wanted to go ahead and clean up the dimensions so they look exactly like this one, we can move back to SolidWorks and realize if I was to drag up and off like this, I can change the way that it shows the actual dimensions. which gives me a little bit more room on my part there. However, as long as they are specified within the ANSI or ASME Y14.5 standards, you're all good. So, and I've showed you multiple ways to do that. So join me in the next video and we'll learn how to model and draw something else. I hope you have a great day and you're able to model your project. So make sure you also save the drawing before you're done. So I'll go ahead and press Save All and save. Now you can have a great day.